All right, let's dive right in. Today, we're going to pull back the curtain on our digital lives and look at the secret architecture that's running everything behind the scenes. It all starts with a blueprint. So let's get into it. I mean, it seriously feels like magic, doesn't it? You search for a song and boom, it's there. But you know what? It's not magic. It's all engineering. Behind every single one of those clicks is a super organized, meticulously planned system for storing and grabbing information. And that system, my friends, is a database. You know, to build anything, I don't care if it's a skyscraper or a digital music library, everyone on the project has to be speaking the same language. In the world of data, that's absolutely true, and that language is the foundation for everything else we're going to talk about. And that language? It's called SQL, which stands for Structured Query Language. Just think of it as the universal set of instructions. It's the official building code that pretty much every major database system has agreed to use. It's actually an ANSI standard, which means everybody's on the same page about how it works. So what does this language actually let us do? Well, it boils down to three really crucial things. With SQL, we can tell a database to store new info, change or update the info that's already in there, and, this is the big one, retrieve the exact piece of data we need at the exact moment we need. Okay, so we've got our language, our set of commands, but what are we actually building with it? What does the structure we're creating with SQL really look like? Well, it is all about organization. We're building what's called a Relational Database Management System, or for short, an RDBMS. Now, the part that's really key here is that word relational. This isn't just a system that stores data. It stores it in a bunch of tables that are all cleverly linked together. It creates this powerful, interconnected web of information. And here it is. This is the absolute bedrock, the fundamental building block of the whole system. Yeah, at first glance, it just looks like a simple spreadsheet. And honestly, that's a great way to think about it. You've got your columns for different categories, like title and artist, and then you have rows, where each row is one unique item. This simple grid is where all that power and speed comes from. So in the lingo of database architects, this entire grid is called a relation, or, just a table. If we think of our database as a big building, then this table is one of the rooms inside designed to hold just one specific kind of thing, like all our customers or all our products. Now let's zoom in a little bit. See that single row in the table? That's what we call a tuple, or an easier way to remember it, a record. That represents one single complete item in our collection. So in our music table, one row is one CD with all its specific details. And let's zoom in just one more time. Each of those columns is an attribute or a field. This is just one specific characteristic of our item. So for that one CD record, its attributes are its title, its artist, and its genre. It's this super precise breakdown that lets us find anything so incredibly fast. So here's the crucial takeaway. A simple database management system, a DBMS, it just handles data and files. But an RDBMS, a relational system, manages all these interconnected tables. And that ability to understand and use the relationships between the tables, that's the secret sauce. That's what makes it so powerful. I mean, you wouldn't just start building a house without a blueprint, right? Of course not. And it's the exact same principle for a database. Before anyone writes a single line of code, an architect has got to design the entire structure from the ground up. And this design process, it's really a journey that happens in three main stages. First up is the conceptual level. Think of this as the initial back-of-the-napkin sketch. Then you move to the logical level, which is the detailed, formal blueprint. And finally, you have the physical level. That's the actual construction phase, where the blueprint is used to build the database in a real system. So that first sketch is called an entity relationship diagram, or just ERD for short. Don't let the name intimidate you. It's basically a simple, high-level drawing. It shows the main things you want to keep track of. Those are the entities and the relationships that connect them. It's like the very first map of our data building. This brings us to what is maybe the most critical step in this whole process. We have to turn that simple conceptual drawing into a detailed technical set of instructions that a computer can actually understand and use to build something. And this is the real engineering puzzle, right? How in the world do you translate these abstract boxes and lines into a logical, efficient structure that can handle millions or even billions of pieces of information without breaking a sweat? Well, it all starts with one of those boxes from our diagram, an entity. And all an entity really is a concept, a thing we want to store information about. It could be a customer, a product, an order, you name it. And that entity has characteristics or attributes like a name, an address, and an ID. And check this out. This is where you see the first rule of the conversion in action. That abstract idea of a customer entity gets translated literally one-to-one into a concrete customer relation or table. Every single attribute of the entity just becomes a column in that table. It's a direct, simple mapping.
And this is not just people making it up as they go. No siree. Database engineers follow a super strict set of rules, a playbook, really, to convert every single part of that ERD. Not just the entities, but also all the complicated relationships between them. And these rules make sure the final database is efficient, stable, and totally free of errors.
And what do you get at the end of all this meticulous work? You get the relational schema. This is it. This is the master blueprint, the complete, final technical plan that lays out every table, every column, and every single relationship for the entire database. It's the final instruction manual before construction begins.
Okay, so you might be thinking, wow, that is a lot of work. So why bother? Why go through all of this painstaking, multi-step design? Because the quality of this blueprint determines, well, pretty much everything about the final product. A well-designed schema is absolutely everything. It's the reason your data stays accurate and consistent. That's a concept called data integrity. It's what makes your searches lightning fast. It's what allows for easy updates. And maybe most importantly, it's what allows the system to scale up to handle millions of users. This careful design is the real secret behind the speed and reliability of every app you use.
So the next time you instantly pull up a playlist or check an order status, you'll know. You'll know about the invisible architecture working hard behind the scenes. From a simple sketch to a complex schema, this is how our information gets structured. The entire digital world is built on these blueprints. So the question is, now that you get the logic, what would you build?